Hello, I suggest you this nice exercise. Let A be a square matrix with complex entries, and we want to find the characteristic polynomial of A inverse. We begin with the definition of the characteristic polynomial. P A of x is equal determinant of x in minus a, where in is the identity matrix of size n is also the degree of the polynomial. So I can write like this: a n x power n plus a n minus 1 x power n minus 1 plus plus a1 x plus a0. I evaluate the polynomial on 0, so I get here 0 times an is 0 and minus a, so the determinant of minus a. Here all this is 0, is equal a0. Since a is the size of a is n, determinant of minus a is minus 1 power n determinant of a. So I find a0 here, and an here is 1, because here all the coefficients are 1, and the product will give 1 to the coefficient of x power n, and a0 is this minus 1 power n determinant of a. For all lambda in C, the complex number, we have the characteristic polynomial of the A inverse evaluated in lambda is equal determinant like this, lambda in minus A inverse. Same definition. So I can factoring by minus lambda a minus 1. Here gives minus a. When I do the product, minus lambda a minus 1 times minus a is lambda a n, and then here I get 1 by lambda in. If I do the product, I have minus a inverse. So here just factoring by minus lambda a minus 1, and I use the formula: the determinant of a product is the product of the determinant, so it's equal determinant of minus lambda a minus 1 determinant of 1 by lambda in minus 1a. This quantity is the characteristic polynomial of A, but evaluated in 1 by lambda. So this is characteristic polynomial of A evaluated in 1 in lambda. In place of x there is 1 by lambda, and here the determinant of minus lambda a minus 1 is minus 1 power n lambda power n determinant of A inverse. The determinant of A inverse is the inverse of the determinant 1 by determinant of A. So I obtain polynomial A inverse of lambda is equal to lambda by n. I can put minus 1 power n in the denominator. It does not change. Determinant of A. I do this for getting the coefficient A0. A0 is minus 1 power n determinant of A. So times polynomial characteristic of A evaluated in 1 by lambda. So this is equal 1 by A0, and then lambda n polynomial characteristic of A evaluated in 1 by lambda. This quantity lambda n PA1 over lambda is a polynomial which called the reciprocal polynomial of PA. It is the reciprocal polynomial of the characteristic polynomial of A. So I can say that the characteristic polynomial of the inverse of a matrix is the reciprocal of the polynomial of the characteristic polynomial divided by A0. So I can take PA inverse of lambda is 1 by A0 lambda n PA 1 by lambda, but PA 1 by lambda is AN 1 by lambda power n plus AN minus 1 by lambda power n minus 1 plus plus 1 A1 1 by lambda plus A0. If I multiply by lambda, I get 1 by A0 AN. I simplify by I cancel lambda n plus AN minus 1 lambda plus A1 lambda n minus 1 plus A0 lambda power n. So the power is increasing. This is why it's called the reciprocal polynomial, because the coefficients are the same, but the power of lambda is increasing. I give you an example. Find the characteristic polynomial of the inverse of the matrix A. So A is 2, 1, 3, 0, 1. I begin with the characteristic polynomial of A. I use the formula x power 2 minus trace of ax plus the determinant of A. So it's x2 trace of A is the sum of the diagonal element. 2 plus 3 is 5. X plus the determinant of A is 2 times 3, 6 minus 0 is 6. This is characteristic polynomial of A. So characteristic polynomial of A inverse is then 1 by A0. A0 is 6. And then I write an is 1 plus 5x plus 6x power 2, which I can rearrange. 1 by 6 times 6 x power 2 is x2 minus 5 by 6 x plus 1 by. This is the characteristic polynomial of the inverse of A. Another method, I calculate the inverse of A. A inverse is 1 by determinant of A. Determinant of A is 6. 2 and 3. I write 3 here and 2 here. 0 and 1. I put minus 0, minus 1. So I do the product. 1 by 6 times 3 is 1 by 2. 1 by 6 times minus 1 is 1 minus 1, 6. Here 0, and here is 1/3. I apply the same formula here. PA minus 1x is x power 2. The trace is 1/2 plus 1/3 is 5, 6 minus 5 by 6 x plus the determinant. The determinant 1/2 by 1/3 is 1/6. I have find the same thing here. There is also another thing, that the spectrum of A is the set of eigenvalue, is the root of this polynomial is 2 and 3, and the spectrum of A inverse is the inverse of the eigenvalue here, 1 by 2 and 1 by 3. Thank you.